Hello students, today we're doing 6.1 on fractions and equivalent fractions. This whole chapter is on fractions, so you will be going through a lot of fractions in the next couple of weeks, and it's going to link back to our chapter 5 that we did also. Okay, so let's start by looking at some fractions and showing you some equivalent fractions. So I'm going to start with a circle and cut it in half. And if I shade one part of that, then this would be, I shaded 1/2 of the circle, right? Okay, let me draw another circle. Oh, and remember, you should be taking notes with me, so you should be writing down all of this. Okay, I'm going to draw another circle, and I'm going to split it into 4s. If I go a little bit too fast in these videos, then you can always pause it and write down what I wrote down, and then hit play again. Okay, so I split this one into 4s, and I'm going to shade in 2 of its pieces. Okay, so that way, this time I shaded in 2 out of the 4. Okay, and then the last circle I'm going to draw, I'm going to cut this one into 6 pieces. Okay, and this time I'm going to shade 3 of those 6. So I shaded 3 out of 6. Now, if you look at these pictures, you will see that if you kind of step back and look at them, you'll see that they are equal parts, right? They all are shaded the same way, okay? They all have pretty much half of the circle shaded, but these other ones, the last two, we just divided up the circle differently. So we got 2/4 and 3/6, but those are all equal to 1/2. So I have 1/2 is equal to 2/4, and it's also equal to 3/6. And I could have split this up a whole bunch of different ways. I could have split it into 8s, and I would have gotten 4/8. I could have split it into 10ths and gotten 5/10. So there's lots of ways that you can split these up and still get that they're equal. So there are numerous, infinite amounts of equivalent fractions. These are called equivalent fractions because they are equal to each other. Okay, so now we're going to learn how to find some equivalent fractions. Okay, so if I had, well, let's just use this as an example right here. If I had 1/2 and I wanted to make it equal to 3/6, okay, well, that would mean I could multiply both of these by 3, and that would give me 3/6. If I multiply something on the top, I have to multiply the same thing on the bottom. So see how that made it equal? Okay, so now in our first example, I'm going to ask you to find a missing piece. Okay, so example 1, and this is A. We're going to have an A and a B. We have 5/8 is equal to x over 24. So the way you find this answer, what x is, that's what we're looking for, is this missing number up here. We don't know what that top number is. In fact, I could do this without any x up there at all. I could just say, hey, here's a blank spot. What goes up there? The reason we put an x is because we are trying to start towards algebra, and they use x's for their I don't knows, for their unknowns. Okay, so I'm going to say, I'm going to look at the spot that has both numbers across from each other, and I'm going to say 8 times what gives me 24. So you can use your multiplication chart, or if you know your multiplication tables well, you'll know 8 times 3 is 24. So that means I have to multiply by 3 on the top, 5 times 3. And 5 times 3 is 15. So that means x equals 15 in this problem. Okay? Okay, let's go back up here where we did this, and I'm going to show you a different thing. What if I had 5/10 and I wanted to make that an equivalent fraction? Well, right here and right here, we did times. Well, let me show you how to do it with divide. I can take this and divide by a number also. So I can divide by 5, divide by 5. And that will give me 5 divided by 5 is 1, 10 divided by 5 is 2. So that means 5/10 and 1/2 are equivalent fractions. Okay, so that's kind of what we're going to do in part B of example 1. Part B says 15/20 is equal to y over 4. So you can have a y or an x or an a or a b. The variable, the letter, does not matter. It's just an unknown. It's just standing there for a number, okay, instead of having a blank. So now I still do the same thing I did down here. I'm going to look at the ones where you have both numbers, no variables, no letters, and I'm going to try to make this 20 into a 4. So the way I do that is I'm not going to multiply because I can't multiply. I'm going to and get 4. I'm going to divide. So if I divide 20 by 5, that gives me 4. So up here I have to do 15 divided by 5. And that will give me 3. So that means y equals 3 on this problem. Okay, so that's the first section and types of problems you will be doing in your work today. Okay, next section, we are going to be talking about cross products or cross multiplication. Those are the same things, cross products. Your book calls them cross products a lot. Remember, products means multiplication. So sometimes you'll hear me saying cross multiplication because that's usually how I say it. Okay, so this is checking to see if two numbers are equivalent. So if I have, or two fractions. So if I have 15 over 20 and that equals 3 over 4, I want to check to see if this is right. So I'm kind of taking this problem up here that we just did. I got 3 for an answer and I want to see if that's right. So I'm going to go cross. I'm going to go across and I'm going to multiply. So I go 20 times 3 is 60. And then I go 4 times 15. And you might have to do some of that work on your paper. Like you might have to go like this and do the actual work. I know that 15 times 4 is 60. So those two are equal. So these are equal because their cross products are equal. Okay? So now let's do a couple of practice ones with this type. So you're going to have a section in your homework tonight where they're going to say, are these two numbers equal? So just a minute. I want to see exactly how they... Okay, so they're going to give you two numbers like 7... Okay, this is example 2. They're going to give you two numbers like 7/9 and 29/36. And they're going to say, are these equal? Okay, so all you're going to do is you're going to multiply 9 times 29 and 36 times 7. And you're going to see if they're equal. Well, I can't do those in my head. So I'm going to, and y'all aren't allowed to use calculators yet. We're getting there. You're going to get to do them maybe after spring break, use calculators. Okay, so 29 times 9 is 81. So I carry the 8. And that's going to give me 18 plus 8 is 26. So this one is 261. Now I'm going to do the other side, 36 times 7. See this one right here, 36 times 7. Okay, and I always put the smaller number on bottom. It doesn't matter which one's top or bottom. It just makes it easier. So 6 times 7 is 42. Carry the 4. 7 times 3 is 21. Plus 4 is 25. So 252. So are those the same? Are their cross products the same? No, so these are not equal. And you might see it in your book like this. 7/9 is not equal to 29 over 36. Okay, so this is the not equal symbol. Okay, so you'll be doing something like that. Super easy. You're just cross multiplying to see if they are equal. Okay, in example 3 and 4, we are going to be simplifying. So we're going to be putting something into lowest terms, okay? So in this is called, in your book, they call it lowest terms. But you might also hear or see on some worksheets, you might see it say simplify, or you might see reduce. All three of these mean the same thing. So if I have a fraction like 12 over 18, and just like up here, let me move up here for a second. Just like up here, 3/6 is not the lowest term of these, all these that are equal. The lowest term would be the 1/2. So I can change 3/6 into 1/2. Okay, so that's what I'm kind of showing you how to do. So right here where we have 12/18, I want to make that into the lowest terms. And the way you do that is you divide by the GCF. So remember in our last chapter, we found GCF of numbers. And some of y'all can find some of them in your head. Some of y'all have to do extra work. I'm going to show you a couple ways to find lowest terms. So you'll have 3 different ways of doing this. Okay, the first one is find the GCF. So you can do this really quickly. Like just know what number can 12 and 18 both be divided by. What's the highest number they can both be divided by? Okay, you can look on your multiplication chart and you just look for the row that 12 and 18 are both in, and 6 would be the highest one. So we're going to divide these both by 6. So 12 divided by 6 is 2, and 18 divided by 6 is 3. So this is my answer. Okay, that's how you're going to do these lowest terms problems, is just divide by the GCF. Now, what if you don't know the GCF? I'm going to show you another way. It's a little bit longer, but it might be quicker for you because it might take you too long to find your GCF. So if you want to do it this longer way, I look at 12 and 18 and I can say, well, those are both even numbers, so I know they can both be divided by 2. So I'm going to divide them both by 2. Well, I get 6/9. Well, that's not the same as this, and I want the same. I want the lowest terms. This is a little bit simplified, but not all the way. So for lowest terms, I need to divide again. So I say, what else can 6 and 9 be divided by? Well, both of these can be divided by 3. And so now I do 6 divided by 3 is 2, and 9 divided by 3 is 3. So see, I got the same answer. I just had to divide 2 times, instead of 1 time. So I had to divide by 2 and divide by 3 instead of just dividing by 6. But that's okay. You can do it that way. It just takes a little bit longer. Okay, and then my last example is going to be the same one, 12/18, but I'm going to show you a different way to do it. And this is really a good way to do it when your numbers are big and you don't have any idea what to divide by. So what you're going to do is you're going to go over here, and I'm going to make some factor trees really quickly. And I can do factor trees pretty fast. Some of y'all can, although some of y'all are still messing up on them. Okay, there are my factor trees. So for the 12, I have 2, 2, and 3. So I'm going to write those up here. 2, 2, and 3. So 2 times 2 times 3 equals 12, right? And then for 18, I have 2 times 3 times 3. 2 times 3 times 3. Okay, and then the trick on this one is we are going to cross out. So remember when we were trying to find GCF, we would circle. We're not going to circle. We're going to cross out the ones they have in common. So those 2 cross out, and these 3s cross out. And do you see what we have left? Yep, the answer of the lowest terms, which is 2/3. So the same thing we got up here. Okay? Okay, so I'm going to do one more for you on this second type. So if I had like 50/75, I would, if I did my factor trees, I would get 2 times 5 times 5 on this one. Okay, so if I went over here and did 5 times 10 and 2 times 5, see how I get 2 times 5 times 5? And then for 75, I would have 3 times 25, and that's 5 times 5. So this one is 3 times 5 times 5. And then I'm going to cross out the ones they have in common. And I just made up this number in my head. This wasn't in our book or anything, and I got the same thing as the one above. So 50/75 is also 2/3. So that means these two are also equal. Okay, so that's how you do this third way of doing things. So you can find the GCF and divide. You can just keep dividing by things they have in common, or you can do their factor trees, their prime factorization, and get your answer that way. And that's it for today. I will see you tomorrow. Make sure you have notes and your homework done.